let's take a look at this question. It's called count the number of k big indices. This is actually a hard problem, and we will see that this is actually not hard at all. So basically, we have to. This is a zero indexed array, nums, and a positive integer k. And basically, we for a given index I, k big for k big to be satisfied, we have to say that on the left hand side, that is less than I, there should be at least k, right? At least k indices which are smaller, and then basically on the right, there should also be at least k which are greater, which are smaller, right? So basically, uh, here we can take when k is equal to 2, 6 we have 2, 3 is smaller, and then 2, 3 here is also smaller. Similarly, for 5 we have uh, 2, 3 is smaller, and then 2, 3 is smaller here as well. So we have k, the answer is 2 here. For 1, 1, 1, there is no indice, which is like where 1 is smaller than the other. And here the constraint is that the length is 1e5, right? So now basic, what is the basic intuition here, right? So basically the intuition can be, sorry, that we can have a max heap, right? Similarly, because essentially the size, uh, the relative, uh, basically ordering matters, right? So let's say we have we slice first k elements, right? So why first k elements? Because essentially, if the heap size should at least, like, we cannot, can we say that like to consider, so let's divide this problem into two parts, this part and this part, right? So let's say that uh, right, so this is the first part and then this is the second part. So yeah, right. So basically, slice first k element. So can we say that there are, at least two elements on the right of index zero? That doesn't make sense, right? Can we say there are two elements on the on the left of index one? Again, doesn't make sense. So basically, we can first slice nums k, right, till k, and we can put that in a max heap, right? Why Maxi? Because essentially we are interested in the top element. So basically, after that, when we take 6 here, right? When we take 6, we can compare whether 6 is greater than other for I, for num, in nums, basically check if num is greater than top of heap, right? So basically, if that is greater than the top, then at least then we know for sure that the rest, so the top of the heap will be the max value. So the rest of the values are obviously smaller. So this guy happens to be the so there are at least k elements in the so basically uh, k smaller on left. This can be simply a set. Um, and let's say that if we do this, right, we can say that. So now here, what we can say is that in this set, right, we can add index plus k, right? So we will add this. Now, basically, what we want to do now is that basically we will add uh, in this heap, right, we will do push of let's say num, right? And then we will do he max heap pop. Why? Because basically we just want the heap size to be k, and we really don't. Once the size is k plus 1, we will so here size will become k plus 1, right? Now we don't really need the largest element, right? Because there are only we don't need the largest element, because we as soon as we have key elements that are smaller, that's good enough for us, right? So now one part of this problem is solved, that we then have uh, key elements. We have a list of indices which are small, which have key elements smaller on the left, right? So similarly, basically, can we do something similar uh, for the for basically this guy, uh, basically similar to the problem, first sub problem, right? So yeah, so basically, what we can just do is uh, a smaller right can also be a set. Max heap. Now here, what will be the max heap? It will begin at what length? This will begin at len nums minus k, right? And it'll go till here, and then basically what else, right? So basically we will see so here let's just try to go over a range. So let's say for index in range len nums minus k minus 1, we can just do this. We can just say num can be nums index. Simple, right? And yeah, basically it's again the same thing, like literally the same thing. As soon as we reach here, uh, we'll just have this. Now instead of adding index plus k, all we have to do is this can be literally index. And then basically for returning, what do we have to return? We just have to return the length of the intersection of these two sets. That's it. So yeah, let's try to convert this to code very quickly. So we have, so here this can be so top of the heap, simply top of the heap is just negative of so basically for index num in this, so basically yeah, uh, this way we can convert this to a max heap at line 29, and then we are enumerating the array. We can then check whether this element is so yeah, this way we can um, so basically what we can do is heap push of heap, right? So heap push, and then we can just do simple enough, right? And then yeah, basically this is one, right? And then basically we can have something similar here, where we'll have, and then so yeah, basically this was an issue, right? So this was index in range. So we need to start picking up this guy, and then basically num is going to be nums of index, right? And then uh, and then basically this is just going to be index because, and then in heap push the same thing, right? We always want to add the guy, add the num to the heap and pop the top value. So, and then basically we can just return this. Let's try to run this. It's saying none time is not. Uh, let's try to print this. Also, heap is none. This is not what we want. So, let's try to print this. Right, and then basically if we just do this, Oh, I see. So basically, heapify returns are null, right? So basically, we cannot do it this way. We just have to do it like, um, cool. So this should be fine. And then similarly here, we cannot do this. We have to do this. Yeah, this should work now. So output here is 31 and how many? Okay, so there are some test cases that are still failing. Is that because of this? We are getting a one-off error, I guess. Okay. So on the left we have three, so that's 0, 1, 2, 3, right? And then we also have 4, we have 5, 6, and then we have 6 as well. Uh, so 6 shouldn't be right. Right. So yeah, so I think it's just this. So yeah, there we go. So basically the error was just that we placed the last k elements in the heap, right? and then basically we start off with k minus 1. So that was about all there was to the solution. If you really think about it, it's actually a pretty easy. So uh, so yeah, and for the time and space complexity, this should just be like basically we have to place a key. We have to maintain a heap of size k, right? So basically, uh, like that should be like k log k, right? And then basically we have to do that k times n times. So this should be plus n log k. So this will finally just be O of n log k. Similarly, space complexity will just we have to maintain two sets, and the max length of the set can just be basically O of n minus k. Um, yeah, so basically the max length can be O of n minus k. Yeah. So so yeah, that's about it.